Hello everyone, we are Yatim students from Group 1 of Industrial Control and Automation class. Our subject code BEKC 3673. Today we are going to present the use of transducer of sensor in drone stabilizing application. First and foremost, let me introduce the team members. We are Chi Yuan, Iqmal, Dyniel, and Sheng. Our lecturer is Dr. Mohd Ruzaini Bin Hashim. There are a lot of sensors being used in a self-balancing drone, such as the accelerometer, the engine test sensors, magnetic sensors, tilt sensors, current sensors, and also the initial measurement unit. However, in this presentation, we will only demonstrate about the accelerometer, gyroscope, distance sensor, and also its controller initial measurement unit. The first sensor is accelerometer. It is used to measure the accelerations of the drone. When the force, which is caused by air vibrations or abrupt movement of the drone, it will cause the mass to squeeze on the piece of electric material, which then produces the electrical charge that is proportional to the force exerted upon it. In this way, the drone accelerations can be detected.
The second sensor is the gyroscope sensor. In the 1816, the advent of the electric motor allowed the gyroscope to rotate without limit. The first functional gyrocompass was in 1904 by the German inventor Hermann. A gyroscope is an easy way to say measure the rate of rotation and help keep the drone balanced. Gyroscopes are the device that consist of molten wheel that spin on an axis that is free to move in any direction. They are used to provide stability or maintain a reference direction. The third sensor is distance sensor. What are distance sensor? As its name suggests, to easily define distance sensor, it is sensor used for determine the proximity of an object without any physical contact involved. This sensor allows drone to fly at a pre-programmed height.
For a drone to fly perfectly, the Initial Measurement Unit (IMU) is absolutely necessary. The IMU collects the data from the sensors such as the gyroscope, which detect the change in rotational attributes like pitch, roll and yaw, while the accelerometer is used to measure the acceleration. These data are be used directly by the feedback control loop to getting the desired height and angular rate of the drone. For the drone to fly in any direction, at first the sensor will detect the actual height and angular rate of the drone. Then the IMU will gather the data from the sensor to determine the current position of the drone. With combination of the desired height and angular rate signals, the IMU will send the new data to the DC motor to adjusting the propeller speed. This data is required for the drone to fly or hover to getting the desired height and angular rate.